afterwards. Let me give you an overview of what I'm going to talk about today. You've heard many sources of PFAS out there. We're going to focus on semiconductors. This talk ties directly into Dr. Helbling's work, which you saw first. We're going to talk about the setting of limits for PFAS and how we're analyzing PFAS, and then finally comparing Dr. Helbling's effluent data to the regulatory regime as it currently stands. So manufacturing chips is a very complex operation. A speaker from March of 2023, Healthy Water Solutions, David Speed, he's affiliated with Global Foundries. He described semiconductor fabrication as thousands of carefully controlled steps to deposit, modify, and remove chemicals. This is a very chemical intensive operation, not just PFAS, but many other things. And you've got to put it in exactly the right amount, exactly the right place, and at exactly the right time. And one of the big challenges facing us, and by us I mean everybody, is the fact that the chemical supply companies want to keep their products proprietary. They do not want to reveal what's in their magic formula to keep a competitive edge. The CHIPS office, which is in charge of doling out the subsidies to the American, this is to develop the American chip manufacturing industry, such as the Micron plant, which is coming to the Syracuse area, has identified wastewater discharges as the biggest risk of contamination to the environment. And this is because of the large volumes of water. You see this average flow. Micron has said that they are going to use up to 48 million gallons a day of water. That's more than the city of Syracuse. So how do we go about setting effluent limits? You've heard from Sarah, excuse me, about what DEC is doing. General picture here is that we have an industrial operation, and maybe I can figure out how this works, maybe not. No, sorry. Oh dear. Oh dear. I should have used my own. Okay. All right. I'm just going to point. So here's our industry.
That's better for the recording anyway.
Yeah. So in any case, often the industry is discharging to a local sewage treatment plant, which then discharges into a waterway. The pollutants coming out of that are diluted, but then they work their way up the food chain. So there's, looking at human health risk, there's two avenues. It's this thing up here. Okay, well, I'm going to use this for, thank you, John. Use the mouse. So the two avenues that we're primarily interested is, from human health point of view at least, is drinking water and also the consumption of contaminated fish. So those are the principal avenues. There's also ecological effects. We're not going to get into that because what do we know about it? Not much. So we can set limits based on technology. Here's where the US EPA is at. They're updating rules for those industries listed, but they are strangely have not pursued the chip manufacturing category. So I'll just leave that without comment. So most of the action has been in this arena, drinking water standards. So New York State currently has a 10 part per trillion limit on PFOA and PFAS. Those two compounds which have certainly received the greatest attention. They have proposed a couple of years ago these other limits that you see listed for other PFAS. As far as I know, that has not gone into effect. DEC can correct me if I'm wrong. The EPA has just, as in last month, come out with recommended MCLs, maximum contaminant limits. Those are drinking water standards. And you can see the timeline is over the next 5 years that they actually come into force. So it's study and then enforced later on. These are the actual numbers. As others have mentioned, PFOA, PFAS, 4 parts per trillion. So we want to look at these maximum contaminant levels. This other next 3 compounds are set at 10 parts per trillion. And in addition, we have this mixture addressing these 3 compounds plus the perfluorobutane sulfonate, which Damien had mentioned as being the one compound that comes up at the highest concentrations, at least in semiconductor operations. I'm showing on the side here, we're near Lake Ontario. That's the source of water for much of Onondaga County. You can see there it's already contaminated with low levels of PFOA and PFAS. It is non-detect for the other chemicals. Don't ask me what the detection limit is, because I don't know, although I suspect it's in the low part per trillion level. Notice that the butane sulfonate is considered considerably less toxic, so it does not count nearly as much. So this gets us into the messy arena of analytical chemistry. Right now, the EPA has methods which have come out in 2024. They're, according to the regulations, are not approved. But this is what people are recommending, what the EPA is recommending. The 1633 looks at this suite of carboxylic acids and sulfonic acids. This is what DEC is also recommending, or telling folks to do as part of its TOGS. But we also have this method, which is called total adsorbable fluoride. What's that? So that's a method where you take your wastewater or your water sample and you pass it through a resin to adsorb the fluorinated compounds. Now that you've concentrated them, you can take them and deconstruct them. You're essentially burning them up and turning them into fluorine. And then you measure really fluoride. This is good old general chemistry here. And the fluoride ion is then analyzed by ion chromatography. So it's not as sensitive. So I'm putting up here detection limits about 1 part per trillion with the GCMS, LCMS method, but about 1,000 times higher for the total adsorbable fluoride. So the good news with the total adsorbable fluorine is that it catches everything, or nearly everything, but it's much less sensitive. You've already heard from DEC about these standards, so I'm going to skip through this. Sarah's talked about the technical guidance. So what we did was we took Damien's, Dr. Helbling's data and compared it to these standards that exist at this time. So here's PFAS and PFOA. And keep in mind, this is not taking into account the dilution that's going to happen. So we're just taking what's coming out of the pipe or being discharged into a sewage treatment plant in the case of FABs 2 and 3. and comparing it to these limits. But this is the best that we can do. It gives us a yardstick at least. So those are the New York State existing water quality standards. Here's the New York State drinking water standards. And then here's where EPA is headed with 4 parts per trillion. But that's not going to come into effect until 2029. Next, we have these 4 compounds that EPA is planning to regulate. Again, there's the 10. Notice we're at a much bigger scale. I've switched to a log format, and much higher concentrations for the PFBS. We're okay in terms of drinking water limits if there's not too many of these other compounds present. And finally, we have the arena of no regulatory limits whatsoever. And there's Dr. Helbling's data. There's the targeted compounds that he talked about. And then here's the non-target, which greatly exceed the targeted compounds. So, if we look at the simple view, the Venn diagram view, we've got over 12,000 known PFAS. There's something like 600 that are used in products. The analytical method, 1633, looks at 40 of those, and much of the focus has been on just 2 of that 40. And much in the semiconductor industry, we see transformations of these PFAS that are used into other things that are unknown, that are unknowable except through the other kinds of analysis that Dr. Helbling's been doing. So we have this conundrum here that we have this category of compounds, highly persistent, bioaccumulative, toxicities, as Phil Goodrum talked about, largely unknown, and we're not going to know for many years. What industry is telling us is we should intercept the compounds, the waste stream early, and because if we let it mix in with lots of other stuff, it's going to be impossible to treat. So, conclusions, I'll do this quickly. We've got to look at more than those 2. Semiconductors is uniquely difficult because there's so many PFAS which are introduced, they're proprietary, and then they get transformed within the process. So we really need to be transparent about what's being used and what's being released. We've got to use the highest state-of-the-art analytical techniques, and so we're recommending using both flavors, the specific compound specific and the total absorbable fluorine, perhaps total fluorine. Treat close to the source, and regulatory, really we should we've got to develop the best technology, or, as Dr. Helbling mentioned, phase the stuff out with find replacements. So thank you for your attention.